Hey robot makers, hope you're having a good day so far. So do you want to build your own Wi-Fi hotspot scanner using a Raspberry Pi Pico W and make it look like a Ghostbusters PKE meter, like this one? Then this is the show for you. So let's dive straight in. My name's Kevin. Come with me as we build robots and other things, bring them to life with code, and have a whole load of fun along the way. Okay, let's get over to our keynotes and have a quick look at what we're going to cover today. So yeah, this is all about the Wi-Fi scanner. So we're going to build this Ghostbusters style Wi-Fi scanner using a Raspberry Pi Pico W. We're going to talk about what the idea of this is, where this kind of come from. We're going to have a look at some of the 3D printed designs and some of the mistakes I've made in building this. This is the sort of final iteration. We're going to have a look at the electronics, wiring this up, how this all fits together. And we're also going to look at the MicroPython code, how you actually do Wi-Fi scanning in the code, a little GUI toolkit that I made, a little widget, and list comprehensions, which is something I learned quite recently and is so cool. Then we'll have a bit of a demo, have a play around with it, and if you're sticking around on the live show, we'll have a bit of a Q&A after, as we always do every week, but that's only for people who are watching on the live stream. Okay, so let's go over to the first bit, the 3D design. So the 3D scanner, the Wi-Fi scanner. So the idea is, remember the film Ghostbusters, and Egon is wandering around and he has this sort of device that looks very similar to this one. I'm not going to switch it on just yet. I'm just going to open this up manually. And it's got these like little white arms that sort of raise depending whether there's like ghosts near or not. I really love that. And when I was thinking about what kind of projects can we do with the Pico W, I'm just looking on my desk one here. So this can do Wi-Fi, it can connect it to Wi-Fi hotspots, but it can also scan for them. Excuse me, I'm still recovering from my cold a little bit, so I've got a little bit of a tickly cough going on. So yeah, this can scan for Wi-Fi hotspots and give you kind of a dictionary of them in MicroPython. So I was thinking, what could we do with that? That'd be really cool. And it kind of occurred to me. So we're going to grab a list of the hotspots that are available that it can currently see. We're going to put that on a display with on a little screen, and we're going to move these servos that control these arms on here, depending on the signal strength of that Wi-Fi hotspot that it's currently got selected. And if you've got many of them, you can sort of go through the list. And it occurred to me that we could put these in like a Ghostbusters style PKE meter, or as was it Ian said, Mark said, sorry, you can, this could be a Pico E-meter. I love a good pun. So that was kind of the inception of the idea. Make some kind of Ghostbusters Wi-Fi hotspot scanner, make the arms move in relation to the strength of the signal, and figure out how to make that work. So that's kind of the idea of the thing. And what I've done is I started sketching out, and this is purely from just visual, pictures I've seen of what that PKE meter is. I've no idea the actual measurements of the one on the film, so this is just my interpretation of this entirely. Excuse me, and I know that it's kind of that shape. It's kind of like got a curvature on it, an arc on it, and it's got kind of a handle which is kind of an oval shape that kind of tapers a little bit as well. So that's kind of what I was starting off with. So usually what I'm doing when I'm playing around with an idea like this is I bring all the components into Fusion 360 and start moving them around to sort of see how this would work. So I started out by bringing in the servo, which is one of these little DS. This is a DS929, I think I might have written this down wrong on a few of my diagrams. 929MG. So that's what this actually looks like if you just look on the camera there. DS929MG. I think I called it DS959, which is probably a mistake. It's got two little mounting holes on it. So I was thinking if this this sits on the bottom of some kind of design. So here's one I prepared earlier. This is like the base. This is a previous version that wasn't quite right for one or two reasons. And the idea is that this servo can kind of sit inside here. Let's try and get this in here. One of the mistakes I made was not allowing enough tolerance, so things got quite difficult to sort of move through. So you can see there we've got the wire sort of just dangling at the back. It does protrude a little bit beneath the bottom. I could make a little bit of a thing to capture that, but yeah, you can see there we've got the servo sort of sticking through. Thank you, Matt Seuss, for subscribing to the channel. So yes, what you can see there on the little picture of me in the corner there, that servo is sort of just sitting nicely in the base there. So really that's what the base is going to do. It's going to house this servo, and you can also see these three little mounting points there. Now I also have these really nice LiPo Amigo Pros from Pimoroni, which I bought last week, and these are a little battery charger. So you can put the battery in and you can connect your device, and then you can charge it through the USB-C there. And it's also got a really nice on-off button there as well. So if I just connect a battery I have here to one of these, just into the battery, like so. If I press the on-off button just by clicking that, you'll get a little LED lighting up. I don't know if you can see that there, lighting up. So it's great, means you can turn your device on and off. So the very first iteration of the case that you can see here, actually, my hand doesn't have any way to sort of turn that button on and off. That's one of the changes I made to this version that I've got in my hand. This didn't have the mounting points as well. So the version you see on the screen there has got the mounting points, and it has the hole, so you can actually push the button from underneath using something like a screwdriver currently, because I've not got a little button protruding there. So that's the first piece, that's the base. Next up is the battery. So another product I absolutely love from Pimoroni, they're not sponsoring this channel, I have just bought these myself, is the Galleon battery. So this one is the Galleon. It's a 400 milliamp hour battery, and it's 3.7 volts. Now the cool thing is you plug this into the Amigo Pro, and it will uplift that voltage excuse me, for the device to 5 volts, which is exactly what we need. It's more or less 5 volts in there. So I needed somewhere to be able to put this this battery. So it kind of sits just underneath the servo there. Now you might notice on that design there, the servo is ever so slightly at an angle. This is because we want the pivot point of the servo to be kind of as left as it can be. That's your right, isn't it? As right as it can be over there. And other than sort of turning the servo around, you're always going to get some part of it sticking out, because this is kind of in the middle of the actual thing, and it has two little arms, mounting points. So there's a few different orientations I could go with, but this is the one I finally settled with, and I just thought I'll put the battery at the same kind of angle just underneath that, like so, and then have the wire sort of trailing inside it. So plenty of room for the battery there. So you can see now that I've just I've kind of gone ahead of myself there. I've mounted, and it's the 529, not 959 servo. Pimoroni also sell those just out of interest, but it's a really nice, it's a Metal Gear servo. It's really, really strong. I've had absolutely no problems with this making it move the arms, so I'm really happy with that. So then there's a middle section. So I actually did a couple of different iterations of this. The very first one was this one here. If I just put this into place, I can show you what this looks like. So this one was a bit of a tight fit, and I'd got some of the measurements wrong on there, so it actually wasn't quite flush. I don't know if you can see there, it's kind of, if I just hide my face, it should auto focus there. Yeah, it's kind of, there's a gap between it, and that's just because some of the measurements I made there weren't quite right. And also the area for the battery is fine, so the battery can kind of fit into this middle section, get it the right way around, and go down to where the compartment is for the LiPo thing. But the LiPo thing, I decided to go for this larger one rather than this smaller one, which is just the LiPo Amigo, just because I can put the battery in and have the device connected to it at the same time. So I basically just enlarged this. So on the second version, let me just grab that one. This one is more like the second version, so it's a yellowish one. So again, that one goes over the, it captures, let's go there, it captures the servo, so that the servo can sort of hold in place there. Let me show you that. And you can see there's a much larger area now for the battery to connect up to, like so, to the Amigo Pro, so that can fit inside there. Let's connect that up like so, and if I've got some screws on there, that would then screw that in place. Okay, the other thing I think on these ones, no, that's correct actually. So that's very similar to the one that I've got in the final model. Again, I think I've just refined some of the tolerances in here, and I think on this particular one, the battery was, if I can just show you that, the battery and where this sort of servo protector thing, it needed a bit more of a cutout on there, so that's the latest version has that. So it keeps everything in place. Now this is the sort of business end, this is a really fun part. The gear-based arms. So these gears are sort of mesh like so, and that means as the servo turns one arm, the other arm automatically moves in the exact same amount, but in the sort of opposite direction. Really nice mechanism, and I learned all about gears when I was making this project. The gear mechanism, the tooth profile, is actually really complicated. It's not, as you would imagine, just kind of like a triangle or some kind of rectangle with smooth sides to it. There's like a real science behind how you go about that. So I think I've got another slide on that in a second. But yes, the idea there, we've got these two white arms. Only one of them is actually powered by the servo, and it moves about 90 degrees from sort of being kind of up like so to being inside the case like that. So it's about 90 degrees. So we need to consider that in our code when we're actually moving this. We don't want to move it 180 degrees or beyond 90 degrees the other way, otherwise we'll just heat up our motor and ruin everything. So then finally the handle. So on the handle I thought, how can I make this really strong and sort of stable? So it's simply, if I just grab the top section here, which you'll see in a second, there is this little lug on there, and it's got a hole, and it's also got, if I just zoom in on that, a little nut capture. So you can just see there's like a little indentation there for a hexagonal nut. And there you can see what it looks like in place. If I get that to focus. Again, it's just trying to find my face there. There we go. So you can see it's just got a little nut capture, and there's the screw on the back. And it's an M2.5 screw and nut. So that's pretty much the design, and then we have the top section. So I've got one of the top sections here. This is the previous one I had. The only difference I've made between this and the previous one is this has a back section. I've called it the back layer, and it's where the arms kind of go in between, and I've not quite got the tolerance right on that. So when the arms went in, they started hitting this edge and sort of stopping, and it was a really sort of tight fit, so I've just changed the tolerances on that and made it so that they sort of sweep in much easier. So other features about this, it has the if the profile, if you look there, it's kind of got this ramped screen protector look, and the idea there is that's kind of what the Ghostbusters one has. If you look at it, they have like a dark one, but it has like a little green screen, a small screen that's kind of squarish in nature. But we won't have a Pico in here, so what I've got, if I just grab that, this isn't a Pico W, you can tell it hasn't got the Wi-Fi bit on, but just showing you for example, the idea is this will sit in here like so, and then we've got some mounting holes. You can see there, if I just take this away for a second, we've got those little mounting holes there, and all we need to do is just screw in some M2 nuts and bolts, and really you just need the screw part. Just trying to grab hold of that. So these are really small screws, again if I can get that to sort of show you there, really small, and you can just screw these in. I've not got my screwdriver to hand, you get the idea. And that means that then that the Pico, the legs are sort of facing upwards like so, and that means that we can put a Pico display pack on there. So I think I've got one of them to hand. They do two sizes, they do these small ones, and then there's the sort of 2-inch version as well. So these simply push on top of the pins. So if I just go for this and push this on top, you can then see that we've got the screen kind of in place where we want it to be. This hole at the front is just so that we can shove any of the wires that we need to get to the Pico. Excuse me, I tried not to cough, but couldn't help it. So that then sort of sandwiches on the top there of the device, and we've got power from the battery going up there. We've got the arm servos, and we'll have the handle on. So this version is just kind of a prototype version I was working on. Okay. So what I've got there, yeah, we've talked about the captive nut, we've talked about the mounting points for the Pico W, the hole for programming the Pico. So yes, the very front of the top section, there is a hole there, which is exactly the right size, particularly the right size for the cable that I have. So when I've got all this plugged in, so let's just grab that and put that back in there. So when it's all sort of fastened up, you'll sometimes want to be able to program this, and you know, it's just easy to sort of plug in a USB cable like so, and then you can do your programming. But the idea is that that isn't plugged in all the time, that's just while you're programming it. And yes, there's the other hole for all the chargers, and the servo wires come through as well. Okay, so the gears, I talked about that being a complicated thing before. So I was going to use the Fusion 360 gear tool. So if you go to the Fusion 360, go to the tool section and then the add-ins, there's like a spur gear plugin. It's installed by default. If you run that, you'll get this little dialog box like you can see on the right hand side of the screen here. And we specify all kinds of measurements for our gear. And you can see there the tooth profile is actually really complicated. So you've got like the root fillet radius, which is kind of a circle, which defines this the very bottom part of the gear. You've got the pitch diameter, which is the pitch is between that point there and that point there. So you've got that a number of times round. The number of times round is the number of teeth, and then you've got this thing called the module, and the number of teeth times the module will define the diameter of the entire gear. So it's not like you can just say, give me a 20mm gear with 20 teeth in it. You've got to define the module to get the correct number. But you can see there, I think, that's probably just a default load of settings that come through. That's not what I actually ended up with. So that was that would give you a circular gear. And then what I then did was just add that to an arm profile that I created, which is just like a couple of swooping shapes. And then I would cut away the bits I didn't need. So basically just overlaid another sketch on top of that and cut away anything that I didn't actually need. I also had to cut away the servo horn section there as well, just so that we've got space for the servo horn to sort of sit inside and move one of the arms, and the other one will just pivot because we've got a little pivot point there as well. So yeah, gears really interesting. If you've got time, I would seek out more information about gears on how to model them in Fusion 360. You could do some really cool projects with it as well. Excuse me. Okay, so let's look at the electronics in this. There's quite a bit going on inside. It's quite simple conceptually. We've got a servo. The servo signal pin is going to GPIO 0 on the Raspberry Pi Pico. It's then got like plus or minus like a ground and a 5 volts. That's just going to the 5 volts on the Pico. The ground is going to the ground. And then they both then also go to the Amigo Pro charger. So I'm just going to cough for a second. So the Pico charger, let me just grab this and we can sort of see a bit closer up on this. So I love this device because it has two connectors on it. It's got the battery connector and it's also got this device connector. So you can buy extra cables such as this one here, which have got the right kind of connector on it. So that's JST PH connector for the power. And you can buy these little packs. I don't know if you can quite see that there, but we've got the PH connector on one side, and we've just got some bare wires on the other side as well. So that means we can then solder them onto our Pico, or I've used the Pico proto board, and we'll have a look at that in a second. And then the Pico charger can also connect to the battery as well, so it can provide connectivity either through by charging it the Amigo Pro charger, or it can take the power directly from the battery if the battery is just on a battery in itself. The Pico display pack simply plugs into the front of the Pico, back side of the Pico, just through the regular pins, and we don't need to do anything else with that. There's no soldering required. It simply pushes into place. Okay, so the other bit of the electronics bits, I've got all these parts from Pimoroni. They're my favourite supplier. You do know I do some work for them occasionally, but they're also a great company. I bought a lot of stuff from them before I started doing the odd video or two for them. So I got the Raspberry Pi Pico W from them. I bought the display too. So this display I was just showing you a second ago, this is the Pico display pack, and they do a slightly larger one. I've got this in a stand at the moment. You can see there it's quite a bit bigger. Sort of 2-inch version, and that's the one I finally decided to go with. I've also got the Amigo Pro LiPo charger, which is a really great LiPo charger. I've got the Pico Proto prototyping board there on the right hand side in the middle. That's really great for sort of doing little projects like this without having to sort of commit it to your Pico. You can just sort of plug it in, do what you need to do, and then remove it if you want. I ended up soldering that in place, so it's kind of committed now. I've got the gallium battery on the right hand bottom side there, and then on the left hand bottom side there we've got the actual servo, which is the DS929MG, not 95 that I've said there. Cool, so that's all the bits and bobs you need for that. You will also need a few other things like the little screws. Let's try and grab hold of one of those. So if I just show you that under the camera, for example, we've got these tiny little screws as well. These are just like little 2M screws, and you'll also need the screw and nut on there, M2.5, I believe. I think that is everything. Okay. So yeah, the Pico Proto, this is a great little board. Again, I picked this up from Pimroni. It's a little prototyping board. It's similar to a breadboard in that there's little connected rows of pins in the middle, and you can then just choose which you want to connect up, and it just makes the whole thing a bit easier to solder. So it has all the pinout labels on it as well, both sides, so depending which side you're looking at. So we're looking at the back of a Pico there. So whereas this is like normally the front, if you flip it over, all the pins are kind of reversed in order. And when this is soldered into place, you can still see which pins are which. So, for example, GPIO is on the very top right of the screen there. And then the ground is sort of the third pin down from that. Okay, just... so it makes things a lot easier to wire up. And I tried to hot glue all these wires I put together into place, and that doesn't stick to the Pico Proto, probably because it's got that solder shield, and it doesn't really allow you to stick things with hot glue. So thank you, Keith, for subscribing to the channel there. So yes, ask me how I know that hot glue doesn't work. I think there's still a little blob of it on there, but not actually doing anything useful. So if you like what I do and you want to help me out with the channel, please make sure you like this video, leave a comment below. Is this a project you're going to try? Have you tried making a Wi-Fi scanner using a Pico W already? And if you've not already subscribed to the channel, you might want to consider doing that too. And just a reminder, if you're watching this on replay on YouTube, I do go live every single Sunday, 7 o'clock UK local time. So it's currently GMT +1, but in the winter it'll be back to GMT. Okay, so the software design. I really enjoyed writing the software for this. So first of all, I was thinking about, I want a nice graphical user interface. We've got a really nice screen. We can do some cool things with that. So I actually went into Canva Pro and mocked up what I wanted the screens to look like. And there's only 3 screens. So there's the very first boot screen, the splash screen, which says Wi-Fi scanner. It's got a little custom graphic that I designed, loosely based off the Ghostbusters logo, but you know, not enough to be sued. Oh, thank you, Kimmy. Thank you for buying me a coffee. Really do appreciate that. And I've also got the official Wi-Fi logo on there as well, just because it makes it look really polished. The next one has got kind of a shrunken down version of that. It says scanning for Wi-Fi hotspots. I originally typed that wrong, I think on some of the social media posts I did. It's got one ending scanning, and it just says please wait. And then the final screen is kind of a placeholder screen. It's got an up and down arrow, and there's a sort of blank area in the middle. And that's where our GUI is going to sort of display a list of Wi-Fi hotspots. So yes, that list box is a little GUI widget that I've designed in MicroPython, and we'll go through that when we have a look at the code in a minute. So very nice and simple screen. There's 4 buttons available on the these screens, on both varieties, so we can use those to do things like make the menu go up and down, and also reset the device or just get it to rescan for hotspots, for example. So yes, the GUI has a list box widget in there. That's pretty much all that it does. We have the arms class, which defines the arms moving up and down. There's the Ghostbusters scanner Pi or main.py, and that's the main application. I can hear my dogs going mental outside. I don't know if you can hear that. Be interested to know if you can hear that or not. That's my dog Minnie and Archie. And the JPEGs simply just needed to be uploaded to the Pico W, and the code will grab them and decode them and display them on the screen. So it's really, really nice piece of work there, just to display JPEGs. Okay, and you do need to upload the arms.py, the GUI.py, as well as the main.py. Okay, so let's have a look at the code. I'm just going to break out now to Thonny, and we can have a quick look at the code. So if I go for that one over there. So I've not actually got a Pico plugged in at the moment. What I can do is I can plug one in to, let me just grab this, plug that in there. Hopefully that's all good. And what I'm going to do, I'm not going to plug it into our actual live one. I'm just going to use this little display I've got on the stand here, just because it's easier to sort of mess about with. So I'm just going to plug that in there. And what I'm going to do now is just click the restart button, so we get our connection there. It thinks this is a Wi-Fi, and it is actually, so that's all good. Yes, this is a Pico W, just checking. Okay, so first of all, I just need to make sure we've got all the different dependent files uploaded. So arms.py, I'm just going to upload that. I'm going to upload the background.jpg. That's the background for the, once it's done the scan and we want to display the widget on there. And we also want to have, let's have a see, GUI, we've uploaded that one. Scanning.jpg, so this is the picture it shows when it's scanning. So I'm just going to say OK to that. And the splash screen is the very first picture that it displays when it boots up, so I'm just going to upload that one as well. Okay, so let's wait for that to finish, and I'm going to go over to the Ghostbusters _ scanner, sorry, the graphical scanner, and this is the actual code that I'm going to run. I'll run it and then we'll talk through a few of the things that are going on there. I'll also just move out the way the buy me a coffee for a minute. So if I just click on the run, we shall then see on the screen on here, oops, so what's going on there? Can't import name HSV to, let me run the main.py instead, because I think that's probably a slightly newer version. Nope. Oh, Kevin, why are you having problems with this? So let me just check the GUI.py, because that's where it's grabbing the HSV to RGB from, I think. So let me just check if that's actually in there. Yep, that's there, HSV to RGB. So I'll just upload that GUI.py just again to make sure that's in there. Okay, yes, that wasn't uploaded, that's the problem there. Okay, let's go back to the graphical scanner and then just click run once more. Okay, there we go. So we've got our little display running first of all, which I'll start this again so you can see it. I'll just put this in front of the camera like so. So let me just run that one more time. It says there's an error there. We'll check through what that is in a second. So the first screen is the splash screen. So let's wait for that to load up. Now, I have had this before. I think my version of Thonny has got possibly a bug in it because it keeps complaining about the back end not working properly. So I'm just going to run that one more time. Right, if you watch that little screen there, you can see Wi-Fi scanner. We've got the little ghost and the Wi-Fi symbol. The LED flashes and then it says scanning for Wi-Fi hotspots. Okay, so it's complaining there about the in the startup line 48. Now Martin was saying that there's an issue with this in his code, so I'm just going to have a quick look to see what is going on there. And it's probably something to do with the file that we're passing to it. So let me just check the files that we've got. We've got splash, list and scanning. So I think it's list is what it's missing. List.jpg, let's just upload that. There we go. And then let's run that one more time. It's just missing the graphics file because that's what it needs to display the final screen on there. So if you see scanning for hotspots, and what we've now got is a list on the screen of all the different in a nice little table. That's a piece of code I've created. So we've got all the different SIDs that it can detect, all the different BSS IDs, the channels, the security, whether it's hidden or not, the security type, and most importantly, the signal strength, because the signal strength is what's going to define the position of the arms as they move up and down. So the other thing I want to show you on close up here, and I'll go over to the overhead actually because it's a bit easier. So if we look on the display here, what I might do as well just on the camera is just drop the brightness down so we can see this a bit easier. Here we go. So we've got a number of Wi-Fi hotspots, and as I press these buttons you can see now that it's going up and down the various different Wi-Fi hotspots that it can find just by pressing these buttons. So that's the widget at work there. And if I just press this button here, it'll just display the Wi-Fi scanner logo for about 10 seconds. I did that so I could take some nice shots of the thing in action. And if I press the other button, it will actually just reset the device and reboot it. Okay, so let's have a look at the code and see what's going on. So I'm going to go over to the graphical scanner, which is the sort of main piece of code, and there's a lot of things that we import. So we're importing networks so we can connect to the Wi-Fi network and scan things. This bin ASCII is a way of getting in there. There's a way of generating random strings in text, and it's always completely different each time. I think we use that somewhere in the code just to detect, just to give our client ID, for example. Pico Graphics is the Pimoroni graphics library for displaying things on the screen, and I'm using the Display Pico 2-inch. If I was using the regular smaller screen, I would take off that -2 for there. We're importing the JPEG decoder, which is a Pimoroni library for decoding JPEGs so you can display them on the screen. We're importing the time and sleep so we can do some sleeping. We're importing the RGB LED, which is the little LED on the front of the screen, which we can flash to indicate something's happening. And also the buttons. Each of the 4 buttons are defined using that button library there. I'm also importing the garbage collection library, which we do gc.collect. Not 100% sure how that works, if that works in the background, but I've seen that on a few pieces of code. I wanted to try it myself. And then I'm importing some of my own classes, so we'll have a look at these in a second. So GUI, we're importing the list box and the HSV to RGB. HSV is hue, saturation and value, and RGB is red, green, blue. And when we're dealing with colours on LEDs, sometimes it's really nice to be able to work in red, green, blue. Sometimes it's nice to be able to work in hue, saturation and value. So why would you want to work in HSV rather than RGB? Well, say you've got a nice red colour and you want to fade that down in brightness. It's really easy to do that with hue, saturation and value because you just drop the value down. If you want to make a red light go from red and then kind of go to white, so you're sort of fading out the saturation, a lot easier to do that with hue, saturation and value. Whereas if you want to define an actual colour, that's probably easier to do with RGB than hue, because hue is it's a kind of circle with a 0 and 1 being at the very top, and depending where you go around that circle between values of 0 and 1, you'll get a different colour. So that's a bit of a non sequitur, I think. But if we want to do things with cycling colours and things, HSV is the way to go. So then there's the arms class, which defines the arms, and the reason I've defined this as a class is because I wanted to have a piece of code that basically makes the arms go to the top, like fully open or fully closed, and I also wanted to have them so that it could clip the value. So if you said I want the arms to go to 100%, they wouldn't go right up like 180 degrees, it would clip at the correct thing, and that was something I wanted to tweak. So that's kind of what the arms do. And then the math function was, I was looking at how you could make some code to make these sweep really elegantly, so they kind of ease in and out with a bit of servo easing. In the end, I didn't bother with that. I just sort of set the servos. I didn't have time to make that work well. And machine, if I wanted to reset the machine, reboot it, which is what I've got one of the pins doing, machine.reset will reset your Pico W. Okay, so I'll quickly go through the rest of the code because this isn't all about the code today. So we initialize the display just by going Pico Graphics display Pico display _2, which tells it the type of display I'm using. And because I've got this rotated 270 degrees, so if that's 0 degrees and I'm holding it like this, it actually has to go like all the way around to rotate to that. So that's what the rotation means. We can then get the width and the height of the display. And depending which display you use, so say you're using like I don't know, one of these Pico Inkies, for example, that'll have a different resolution, a different width and height. I can get that to display there. That'll have a different width and height than say the Pico display or the slightly larger Pico display 2. So that's a really nice way to say get bounds. We define all the buttons, they're the pins 12, 13, 14, 15. And then we create a servo. So we say s equals arms 0, and I'm passing through their pin 0 for our servo. And really this is just a wrapper around a regular servo class, and then we enable that servo. We do the same with the LED. We just define those the 3 pins red, green and blue, and we just define that in the RGB class. And then that LED we can then just set to black 000. And then I just print out to the screen what the width and the height is, just so that when I was debugging it, I can make sure everything works. I then defined 3 file names for the splash screen, the background list file, and also the scanning.jpg. And then I've just defined 2 colors because we use the set pen function and create pen to display text and rectangles and things on the screen in a particular color. So it's a lot easier to define it there than having to work out lower down and mess up your code. I've then got a piece of code that defines the sort of drawing of JPEGs on the screen. So you just pass in the display that you've defined and the file name, and the rest of the code will basically just display that image on the screen at full scale. We then have a get column width, and this is to do with that nice little table that I've got on the bottom of the screen. If I just scroll up there, this little display here. There probably are some table routines to draw things in nice tables, and what I mean by nice is you pass in like 4 characters like SSID. You need then to count the right number of spaces of the maximum thing within that column. So you need some code that will count the maximum width in a particular column. So you have to have a loop, like a for loop, that says, you know, is this the maximum one? No. Is this the maximum one? No. And so on. And then set some kind of variable that says for this column, this is the maximum size. And when I was looking at code, I found this really, really nice feature of Python that's called list comprehensions. If you've never done list comprehensions before, I advise you to seek out more information about this, because it makes your code so much more easier to write and understand. So for example, I'm going to pass in a bunch of columns, essentially a big table of data, so rows and columns, a 2-dimensional array. And that's going to have, for each row is going to have an SSID, a BSSID, channel security, hidden security type, and strength as each row. And what I want to do is just count for each of those what the maximum width is, and return that as just an array of maximum widths. I don't need it for every single row. I just need one array that has the maximum width for each column. So this is how you do it in a list comprehension. So widths equal, and then you have to use a square brackets, and that means this is going to be a list comprehension. And it's a bit like a for loop. You can see there it says for the rows in column, and we say what is the length of the row. So, and each particular, I mean, it really should be called cell, I guess, but for this particular cell here, this row, what's the length of that? So this might be 21, for example, and then it will say for each of them in each of the rows and columns that you're going through there, for columns and columns. So this is probably the not best example to explain how list comprehensions work. I've got another one there, for example. So I'm returning the maximum row for each row in the new list. So that reads a bit easier. I'll probably do another show on list comprehensions, because this is just a bit of I've used a couple of them there. So for example, that new list is also a list comprehension, but it uses something called zip. And what zip does is, if you have, so in this example where I've got a list of Wi-Fi hotspots, each row is a Wi-Fi hotspot. I want to get the strengths of those Wi-Fi hotspots, and I don't care about everything else that's in there. But if I just want to have an array of those strengths, I would have to have a for loop that would say read in, and then just get this last element of the dictionary, and then put that in a new list and append that to this new list. That's a really messy way of doing it. And there's a function called zip in Python, which essentially transposes rows and columns. If you've ever been in Microsoft Excel and you've got some tabular data, instead of going left to right, you want it to go top to bottom, you can do a transposition. You can transpose the data. Zip start will do exactly that. So that's a really nice little tip I found for doing this. So that's quite a complicated bit of code going on there. We've got 3 list comprehensions. We've got one that transposes information, and it just returns the column widths as a single dictionary of all the different columns. That there's 6 columns. Is it 1, 2, 3, 4, 5, 6, 7 columns, or we just want one row with 7 columns of maximum widths. Then we're going to draw the actual stuff. So I define what the headings are. So SSID, BSSID, and so on. This is all the standard stuff that comes back when you do Wi-Fi scan. We'll have a look at that in a second. And this is going to draw these out on the screen. So we set a nice empty data thing there. We append the headings to that, and the column data that we're going to pass in, we then extend the list with columns. So you append first of all, and then you extend to that appended column of data. So then the columns equals the data. We can then get the column widths of all those columns. So we just figure out how wide this needs to be, so we can put all the right spaces and dashes in. And then we can say, what is the number of hotspots that we've got here? So it will count through. You can see there it says hotspots found 12. That's the length of columns -1, because you start at 0. So if you have 0, 1, 2, 3, 4, that's actually 5 things. So you basically just want a -1 to get the number that you're after. Okay, then we have another little for loop that will let me figure out what this does. This will draw It'll figure out the spacing that's required and draw them for each of the lines. So this funny little piece of code here basically draws the right spaces that we need. So SSID and then space, 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 space. It figures that out based on the spacing that we need. And the spacing is from the column widths that we've just defined further up. And the index is the index from that for loop. So that's just a way of saying for each one of these rows, figure out how many spaces that you need to have across. Just so you can tabulate the data. That's really what I'm saying. Okay, and then we print the underlines. So again, we've got another little print thing there that will just go through the column widths and print the number that it needs per column width. And it will print a little space at the end of it. So you've got a little gap there. That's what that end thing does. And then what we then do is just for each of the rows in the columns, we just print out that data, again, using that funny little symbol thing there where we've got the little formatting thing that will do the correct number of spaces. Okay, I didn't explain that very well, but it isn't about how to do string formatting in this particular show. It's about Wi-Fi hotspots. Right, so this is the business end. So scan Wi-Fi. So this is going to connect to our local area network. So WLAN equals network, WLAN network station interface. We then set it to true. And then we say Wi-Fi list equals WLAN.scan. That's all you need to do to get a list of Wi-Fi hotspots, WLAN.scan. And we're just putting that into a little variable called Wi-Fi list. And that list will have, I think I actually print out somewhere on the screen. Maybe not actually. And it essentially contains a dictionary of these things. So the SSID, the BSSID, the channel, and so on. And what I then do is I break all those out just by looking at each element in the array of things that have come back, and then I append them to a new list. I could do that in a list comprehension. If you ever see the creating some empty list, having a for loop to populate that list and appending to that list, that's exactly where list comprehensions can make your code just one line. But I am doing quite a lot of work in there, and it was just easier to sort of see this visually and then figure it out. Okay, and then it just says found and then the SSID. So you'll see there, it's found all these SSIDs. They don't always have a name. Sometimes they're blank, but it has found one. And then it says processing complete. This is more like debug code. This, it shouldn't really need to have all these print statements in there. And what it then returns is the list of all the things that it's found. So that's that. Shortlist will simply just take the SSIDs and return the list of SSIDs, because that's all we need for our little widget. And draw list draws the list that we've just created, that shortlist, on our display. So you can see there we've got things like setting the font to bitmap 8, define what the line height is, so 10 pixels times the scale, and I've got this at scale 2. I display the text at scale 2 down there as well. And I say for every item inside the list, text, display the text, whatever the item is, at 10 pixels in, whatever the current line is, which is set up here. And we increment that current line times the line height so that we get one on each line. So that's it. Then we return that shortlist. I then got some LED things that I played around with and then probably just ditched. So sparkle LED makes the LED sparkle. We've got green, RGB green, which sets it to green. And flash yellow, which is one I do use as it boots up. It flashes a number of times that we specify in there. I've also got the map function because I want to map the percentage that you provide, like between 0 and 100%, and then clip that between the range of values that the arms can move up and down to. So the mapping thing simply just maps one range of values to another range of values. And what I then do is figure out the signal strength is provided in dB. It's like, it's not decibels, is it? It's some measurement of noise. It might actually be decibels. Do you know, I actually don't know, but it's minus dBs. You can see there on the bottom of the screen there all the different minuses, and we can see which is like the strongest one is whichever has the lowest number. The weakest one has the highest number, so like 85. That's probably the worst signal there. That's probably a neighbour's Wi-Fi hotspot. And what we then do is we basically just pull out the signal for each of these and then map the range of that signal. And we can then basically just convert whatever that dB is into a percentage value that we can then set the arms to. I created this clip function basically just to have a minimum and maximum range for the arms, so when the arms go up, they don't go all the way up and smash through the plastic, or the servo will just overheat because it's trying to force against the plastic. So that basically just checks for a minimum and maximum value, otherwise it just passes through whatever the current value is. Okay, and then the very last bit is how we start up the code. So we close the arms, we draw the logo on the screen, we set the value to 0.9, which means closed, I think. So it's like 90% closed. We then swoop the arms, which is a function I created, basically just moves the arms in a sort of fashion given a certain duration. So 3 seconds between 40% and 90%, and then swoop between 90% and 40%. So it should go up and then down. Don't actually know if it does that or not. Let's just switch it on and see, does it actually swoop up and down? I do that. Yes, so it swoops, goes up and then goes down. And let's just turn that back off again. Okay, and then what it then does is flashes the LED on the front. So that little LED will flash 3 times. It will then draw the scanning picture. So it'll say scanning for hotspots. And once it's scanned the Wi-Fi, which is that code up there, we get that list of Wi-Fi hotspots. We then draw that table, which is what draws to the terminal. We draw the JPEG, which is the background for the widget, and then we return the list that we've created. Then what I do is I draw the list box on the screen. So the list box is the little widget with the red bar across, and depending whether you press up or down, it will move that red highlighted bar up or down the list. So what we then do is we just read in the buttons, and there's 4 buttons, A, B, X and Y. So I've currently got button B, which is the one on the left hand side on your screen there, to reset. So it'll just reboot this thing. The one on the other side, A, will just read in the Wi-Fi hotspots again. Oh no, on this one it'll display the graphic. I was just trying to get it to do that for the photograph, the thumbnail. And then X and Y, the bottom 2, basically move the bar up or down. And depending on which one you've currently got selected, it will then set the servo to that particular signal strength. And then it'll just redraw the box. And that's it. That's the code. So let's give this a go. I'm going to go over to the overhead camera just because it's a bit easier to see this. I'll do it 2 different times. I'm just going to move the camera back to that bright position. So this is what the thing looks like. You can see there I've got a bit of blue tack just holding that very long wire in place there. And the little hole that's on the back there is just how I switch this on. So there you go, Wi-Fi scanner. Little LED flashes 3 times. It says scanning for Wi-Fi hotspots, and then it's found some. So it's got a list. I'm gonna turn the camera brightness down in a second so you can actually see this. But as I move up and down the list, depending on what the signal strength is of the Wi-Fi hotspot that it's found, it will move the arms in or out. So what I'll do, I'll just dial back the brightness again. I do that, and we can see the user interface a lot easier now. So if I just restart this by pressing that button there, so it'll say Wi-Fi scanner. Sometimes it does this twice, I'm not sure why that is. We've got 3. Scanning for Wi-Fi hotspots. And there they are. Oops, it's just rebooted. I think this is probably the battery's a little bit low. I have got a whole bunch of batteries next to me here, but I do have to take it apart to do this. See if it'll do that again. And what's happening is when the servo moves, it does take quite a bit of power to do that. Right, I think we're okay. So if I press this down now, you can see that it's sort of moving the arms depending on the signal strength. I could add the signal strength to the menu there just so you can see what that is. But that BT Wi-Fi one is very, very low, hence the arms being right in. Home is probably the strongest one because I think that's probably about 1 meter away from this. There's a few hidden ones. The reason Home's listed twice is I think there's multiple of them. There's another one in the house, and then there's Apple Network Extreme, which is another one which is in here. And there you go. So let me just dial up the brightness one more, and we can see the whole thing a bit easier. So yeah, if you look down there, you can see the that's where we can connect up the cable if we want to program this. You can see from the side view, we've got the Pico, and we have that Pico Proto. You can just see the edge of that in there. and the whole bunch of wires here. I kind of made a bit of a mistake when I was wiring this together. So whereas the servo has this DuPont cable with 3 things sort of connected together, that's there. I intended 3 wires to be within here, and you could just plug that cable back in, but I actually made a mistake and had the exact same connector type, so the female connector type on both ends, so I had to find another DuPont cable, which is this one here, with 2 males, and plug it in there. So the cable's about twice as long as I want it to be, so I could basically just make those a lot simpler. But yeah, you can see that works really nicely. It's pretty quick to react. The thing I really like is how smooth these move. So I've got the tolerances really correct on there. You can see how they work, and you can just about see the servo horn just there, like so. So there's just one servo turning both of them because of that gearing mechanism. You can see the servo does protrude ever so slightly there, but just because of the shape of it, I wanted it to be you know, the right kind of size really. So there we go. I'm really pleased with how this works. And then on the back there, you can just see the LiPo LEDs just in there. And at the moment, I haven't got a button on there to press nicely. I need to 3D print a little button. So I can just press it like so. And then it goes to sleep. And then there we have it. So we have a really nice Wi-Fi scanner that looks just like something from a prop from the film Ghostbusters. Okay, let's go back over to the keynote. That's the code. And we did a bit of a demo as well there as well. So if you want to join me on Discord, we have a Discord server. If you go to action.smilesfan.com/join-discord, you can join our Discord server. And that's a really growing group of people who want to talk more about robots and meet all the other people who are in our little growing group of people who love robots. If you want to help the show as well, you can do a super chat on this particular live stream if you're in the chat now. And we're going to do a bit of a Q&A in a second. You can also do a super thanks if you're watching this back on replay. So there's a little button on the bottom of the screen on YouTube that says thanks. If you press that, you can sort of send through a thanks. You can also go to buymeacoffee.com, which is, if I go over to that one there, buymeacoffee.com/Kev McAleer is another little site if you want to help support the show. And a few people do, and I really appreciate those people doing that, because it means we can continue doing these shows for a little bit longer, because that means I can buy all the components and bits and bobs I need to create really great content. Also pays for the website hosting, the graphics software, the streaming software, which is like a subscription based thing, and all the equipment I have, all the overhead cameras and lighting and sound and microphones and whatnot. Okay, so I think that is everything I wanted to cover off there. And there's also the YouTube membership. You can just click join, and that also helps with the show. Okay, so this is the point of the show. If you're watching this on replay, I'll say thank you very much for watching. I shall see you next time.